Hi everyone. Today we're going to study solution by cross multiplication method. Given a pair of linear equations in two variables, here are the steps of cross multiplication method. Step 1. Write the given equations in the form a sub 1 x plus b sub 1 y plus c sub 1 equals 0. A sub 2x plus b sub 2y plus c sub 2 equals 0. In short, we're going to put the right side of the equations equal to 0. Step 2, we're going to rewrite these equations into this form: x over b sub 1 c sub 2 minus b sub 2 c sub 1 equals the variable y over c sub 1 times a sub 2 minus c sub 2 a sub 1 equals the constant 1 over a sub 1 b sub 2 minus a sub 2 b sub 1. In order for us to memorize this formula, this figure can help. Let us write the x, y, and the constant 1 in the first row. Then we arrange the coefficients and constants in this manner. This is the column for b, so b sub 1, b sub 2. This is the column for the constants, c sub 1, c sub 2. This is the column for a, the coefficients of x. So we have a sub 1, a sub 2. Another column for b, the coefficients of y. So b sub 1, b sub 2. Now look at this first fraction here. This is the fraction for x. So the x is on top and the denominator is the b sub 1 multiplied to c sub 2. Then minus b sub 2 times c sub 1. Next, the second fraction. This is for the y. Y will be in the numerator. In the denominator, we multiply c sub 1 times a sub 2 minus c sub 2 times a sub 1. And the last fraction. The constant 1 is the numerator. In the denominator, we multiply a sub 1 by b sub 2 minus a sub 2 times b sub 1. Then step 3, find x and y. Provided a sub 1 times b sub 2 minus a sub 2 times b sub 1 is not equal to 0. Now let us see the relationship of coefficients of pair of linear equations. Given the lines represented by the pair of equations, you can see here the right side are equated to 0. First condition, when the ratio a sub 1 over a sub 2 is not equal to the ratio b sub 1 over b sub 2, we get a unique solution. Second condition, when the ratio a sub 1 over a sub 2 equals b sub 1 over b sub 2 equals the ratio c sub 1 over c sub 2, there are infinitely many solutions. Third condition, when the ratio a sub 1 over a sub 2 equals b sub 1 over b sub 2 but not equal to the ratio c sub 1 over c sub 2, in here, there is no solution. Example 1. From a bus stand in Bangalore, if we buy 2 tickets to Malleswaram and 3 tickets to Yeshwanthpur, the total cost is 46 rupees. But if we buy 3 tickets to Malleswaram and 5 tickets to Yeshwanthpur, the total cost is 74 rupees. Find the fares from the bus stand to Malleswaram and to Yeshwanpur. We let X to be the fare going to Malleshwaram. We let Y will be the fare going to Yeshwanpur. From the condition given, we can see that 2x plus 3y equals 46. Next condition, 3x plus 5y equals 74. For the step 1, we equate both equations to 0, meaning the constants 46 and 74 we transpose to the left, so it becomes like this. For step 2, we will now use our formula. Then we will substitute the corresponding values. So we have x all over 3 times negative 74 minus 5 times negative 46 equals, for the y fraction, y in the numerator over negative 46 times 3 minus negative 74 times 2 equals 1 over 2 times 5 minus 3 times 3. Simplifying the denominator, in the first fraction we have negative 222 plus 230 equals the middle fraction. The denominator now is negative 138 plus 148 equals third fraction 1 over 10 minus 9. Simplifying the denominators respectively, for the first fraction we have 8 equals, second fraction the denominator is 10 equals, third fraction denominator is 1. Now step 3, we will solve for x and y respectively. What we will do here, this first fraction x over 8 we equate to the third fraction 1 over 1. Now, solving for y, we equate the y over 10 equals the third fraction, 1 over 1. So, it becomes like this. X over 8 equals 1 over 1. And for the y over 10 equals 1 over 1. When we cross multiply, we can solve for the values of x and y respectively. So, the x equals 8 and y equals 10. In the beginning, we said that x is the fare going to Malleshwaram and the y is the fare going to Yeshwanpur. So we have 8 rupees, that is the fare to Malleshwaram, and 10 rupees, that is the fare going to Yeshwanpur. Example 2. For which values of p does the pair of equations given below has unique solution? We have 4x plus 4y plus 8 equals 0, 2x plus 2y plus 2 equals 0. For the given pair to have a unique solution, the ratio a sub 1 over a sub 2 should not be equal to b sub 1 over b sub 2. When we substitute the corresponding values, we have 4 over 2 should not be equal to p over 2. We can see here that we can multiply this inequality by 2. So, p should not be equal to 4. Therefore, for all values of p except 4, the given pair of equations will have a unique solution. Example 3. For what values of k will the following pair of linear equations have infinitely many solutions? Kx plus 3y minus the constant k minus 3 equals 0. 12x plus ky minus k equals 0. For a pair of linear equations to have infinitely many solutions, the ratio a sub 1 over a sub 2 equals b sub 1 over b sub 2 equals c sub 1 over c sub 2. Let us substitute the corresponding values from our given linear equations. So we have k over 12 equals 3 over k equals negative k plus 3 over negative k. We can see here we have three parts of equations. We have the left side, the middle part, and the right side. Let us equate the left side and the middle part, then we solve for k. So we write k over 12 equals 3 over k. When we cross multiply, we will have k squared equals 36. Then we take square root of both sides. So we will have two values of k as positive 6 and negative 6. Now let us equate the middle part and the right side. Then we will solve for k. 3 over k equals negative k plus 3 over negative k. When we cross multiply, we have this negative 3k equals negative k squared plus 3k. The right side members we transpose to the left side. This is positive 3k. When it is transposed, it becomes negative 3k to be combined with the negative 3k on the left. So we have now k squared minus 6k equals 0. We can factor out the common k. So we have k times the quantity k minus 6. When we equate each factor to 0, we will have two values of k. So k equals 0, also positive 6. We can see here, in the first condition, we have two values of k, positive 6 and negative 6. In the second condition, there are also two values of k, 0 and positive 6. Note that the positive 6 is a common solution to both conditions. Therefore, k equals 6 satisfies both the conditions. For this value, the pair of linear equations has infinitely many solutions. So our answer here, k equals 6.